The Greek letter theta means the measure of an angle, and we need to have a common way or consistent way that we draw angles. The initial side of an angle in standard position lies on the positive x-axis. So that is how we're always going to start our angle, is put the initial side on the positive x-axis. That way we're consistent every time. The first method to measure an angle is in degrees. So how many degrees complete a circle? We know that if you go 360 degrees, that takes you all the way around one circle. So what we're going to do to be consistent is we're going to always graph our angles on an XY axis. So we have our initial side on the positive x-axis, so this right here is our initial side, and then we're going to go counterclockwise for positive angles. So once we get to 90 degrees, we can see right here is a 90-degree angle. And then as we keep on going around, there's 180, and then another 90 will give you 270, and then another 90 is 360. So we look at our 1, 2, 3, 4 quadrants, and we have our 0, 90, 180, 270, and 360 degree measures. So if we want to draw a 45-degree angle, we have our initial side on the x-axis, and we just estimate where 45 would be. So you would estimate right around here, this angle would be 45. Okay, so you can put the 45 in the angle or out on the terminal side. Okay, so the ray that it ends on is called the terminal side. You can put the 45 out here. So if you do the first few quickly, positive angles are counterclockwise, and clockwise is how you count or draw negative angles. So here's the first several. Okay, they're pretty straightforward. And again, usually you put the little arrow in there to show which way you're drawing the angle. Okay, so nothing too crazy there. The second way to measure angles is with radians. And what a radian is, an angle measure of 1 radian intercepts an arc length s equal to the radius of the circle. Here's an applet from Desmos to show you the idea of a radian. It's not real easy to get right off the bat. But again, you have the radius of our circle, in this case 1. So if I let the angle measure be 1 radian, okay, so little a here is 1. That's just how they labeled the symbols on here. So this angle measure right here represents 1 radian. And what that means is the length of the radius is equal to the length of this arc on the circle. So you can picture a string stretched from 0 to 1 and then kind of fold that string around the circumference on the circle, so on the arc of the circle, and that distance of 1 would be the same length as this arc length right here. So the angle of 1 radian means you have the equivalent of 1 radius length on the arc of the circle. If I make that 2 radians, what that means now is that I put 2 radii on the circle. So the first one ended about here, and then the second radius is here. So as I go around, notice that when I get to 3, I'm almost at a straight line, a 180 degree angle. But if I go to 3.1 and then 3.2, it skips over it. Well, what we're going to notice is 3.14 is the value that'll make that a straight angle. And we'll talk about that in a second. But again, what radian measure means is the 1 radian means that you have put 1 radius on the circle. If I make the circle larger, so there's a radius of 2, notice that the angle is still the same size, but now the radius is 2, which means if you take a string from 0 to 2, that length, and stretch it around that arc of the circle, that arc will have the same length as the radius. But again, notice the angle is the same. So as I make the circle larger, notice that the angle isn't getting larger. The length of the terminal side, the length of the radius here is getting larger, but what it's opening to, this measure right here, is still the same size. Okay, so you can see that. And as I go all the way around the circle, okay, right there, right at 270 degrees, we're at about 4.7 for the decimal. And what that is will be 1.5 pi. As we go all the way around, right, notice how 6.3 is just past the x-axis. Well, that'd be 6.28 because that would be 2 pi. So if we look at our angle measures, 0 degrees will be the same thing as 0 radians. Basically, you didn't go anywhere. And then as you go to 90 degrees, and then 180, 270, and 360, let's think about how many radii would be on the circle. Well, remember, the circumference of the circle is 2 pi r. So there are 6.28 radii on the circle, because 2 pi r, if r is 1, then there are 6.28 radii on the circle. So whatever r is, actually, there's going to be 2 pi of them on the circle. So all the way around is 2 pi radians. If we go half that, so from 0 to 180 degrees, that's half of 2 pi. Well, half of 2 pi is 1 pi. So 180 degrees is in the same location as pi radians. If we do half of that, that'd be half pi, which is pi over 2. So 90 degrees would be pi over 2 radians. And then if we go around the circle again, we have 0, half pi, 1 pi, and then 1.5 pi, or 3 halves pi, and then 2 pi. So the 4 quadrants break your 2 pi into 4 equal parts. So pi over 2, 1 pi, 1.5 pi, and then 2 pi. One thing you have to be very careful of is, one thing confusing about radian measure is sometimes they will give the angle in terms of pi's, like pi over 2, and other times they'll give you the decimal values. So when you look at pi over 2, if you divide 3.1415 by 2, you get right around 1.57. So 1.57 radians would be equivalent to pi over 2 radians. Pi, we know, is 3.14. And these are, I'm just rounding to the nearest hundredth. And then if you do 1.5 pi, you get about 4.71. And then 2 pi is about 6.28. So if you're asked to draw an angle and you're in radian mode, you may also look at the decimals starting at 0, 1.57, 3.14, 4.71, and 6.28. So if they told you to draw an angle of, say, 2 radians, well, 2.0 we know is between 1.57 and 3.14. If they said to draw an angle of, say, 5.1 radians, well, 5.1 is between 4.71 and 6.28. So that will be down in the 4th quadrant here. Okay, so again, just make sure that you recognize these decimal values as the equivalent of the radian measure when they use pi in the representation. So here are the answers to the drawing the angles in radian measure. And again, what students will get confused with is we'll see 1.5 pi, and students will get confused between that and just 1.5. 1.5 would be up in the 2nd quadrant because, up in the 1st quadrant, because 1.57 is pi over 2. So 1.5 would be in the 1st quadrant. But 1.5 pi is 1.5 times 3.14. And that happens to be where the 270 degrees is. Okay, and then on the last one, the 2 pi radians, you start at 0, go around, and you end up right up on the x-axis again.